now we have moved on to the fourth lecture of this series of basic signaling systems. Here now, as we have seen what are the different types of signals. So, now in this lecture we will see what are the different operations we can perform on the given signal in the coming lectures. Okay, let us see. See, though basically these are the different operations which we can perform on a continuous time signal. We can perform this operation on discrete time signal also, but we will see how we can perform on the continuous time signal. So, basically these are the 5 to 6 basic operation which are done on the continuous time signal. First is time reversal, second is time shifting. So, what is time reversal? See, if you just make time as negative, then that is time that is called time reversal. What is time shifting? If you add some time or if you subtract some time from the given function, that is called time shifting. Again, what is amplitude scaling? If you multiply some constant to the signal, so that is a magnitude get so that is amplitude get increased, and that is amplitude scaling. Again, we have addition. Addition is basically how if you add two signals, then what will be the output of final signal. Then we have multiplication where we multiply two signal. So, we will see. Again, the last is time scaling. What is time scaling? Scaling means suppose the signal is from certain time duration. For suppose the signal is from t is equal to 2 to t is equal to 4. So, now if you multiply this time, it will become, so y t basically is x t, or if you keep a is equal to 2, then it will become y t is equal to x 2 t. So, we will see how if you multiply 2, what will happen to the signal, it will advance or will it will delay, we will all see in the upcoming slides. Okay. So, let us study those things in detail. The first one is basically the time reversal. What is time reversal? See, what we have seen a unit step signal. How we represent unit step signal? See, basically this is a representation of unit step signal. This is the graph, here we have 1, this is the time axis, this is the y t. Basically y t is equal to u t, this is the representation of a unit step signal. So, if you do time reversal here, that is multiplying, what will happen? It will turn exactly opposite on the y axis. So, earlier the signal was existing. So what was the unit step signal? Signal which was having no value for t less than 0, and we are having finite value for t greater than 0, will now exactly turns 180 degree backward. So, this is the basically u minus t. This is basically u minus t. See, this is for u t, it is having value 1 for greater than 0 and 0 for less than 0. Now, if you multiply the time by minus 1, that is called time reversal, then what will happen? It will become exactly opposite, it will turn 180 degree in the negative x axis. So, this is basically the representation of minus t. Similarly, suppose you are having a ramp signal like this, and basically this is the ramp signal, y t is equal to r t. If you multiply r minus t, if you reverse the signal, what will happen? It will turns like this, it will go into the negative x axis. So, this is the other representation. See the signal, or you can also say if you so this was the peak, what minus 3, now the peak will shift where to plus 3. The minimum of the signal was at plus 3, so the now minimum will go to minus 3. So, generally the output signal y is reflection of input signal x about the vertical line. So, basically time reversal means taking the reflection of those signal on that y axis. Okay. This is the other way of calling this time reversal, also known as reflection. Now, the other is time shifting or time delay. What is time shifting, time delay? See, now when you wrote ut, that means the signal was starting from t is equal to 0. The signal was starting from t is equal to 0 and it was going till infinite. But suppose now I want this signal to start from t is equal to 2. So, what we will do? So, how we can say the signal start from t is equal to 2? See, suppose this is 0, 1, 2. So, if we make it like this at t, so this is basically what? This is u t starting from t greater than 0. So, if we write mathematical form, then we can write it as u t is equal to 1 at t greater than is equal to 2 and 0 for t less than 2. this is the mathematical representation, and but this is the basically how we have shifted the signal by what value, by 2 seconds. If you say time is in second, so what we have done, we have shifted the signal by 2 seconds. So how we do, let us see. See here, so yt is equal to xtd. So when we subtract time, we call it as time delay. When we add it, we say time advancement. If we subtract time, we will say time delay. If we add time, we will say time advancement. Again, shift the signal left or right. Adding time shifting means we want to shift the signal to somewhat to right time or something to the left time. Okay, shift the original to the signal. Now, what is the rule? See, set the argument equal to 0, then move the origin to of x2 to td. See, let us see with the example. See here, what we have done, whatever is the increment in C when we have t minus 2. See, one more way to understand this is, when you are saying ut is equal to ut minus 2. So what that mean, delay in time is what, earlier whatever your output you were getting at t is equal to 0, now that output should come at t is equal to 2. This is basically, see, function should remain same, the value of function should remain same. It should not be like, see, suppose if this is a signal, the modified signal, and this was the original signal. So whatever operation you perform on signal, the nature or the characteristic of signal should not change. So in this, what was happening earlier, the signal was having value t is equal to 0, we are having value 1. So in this form also, what we will do, if we keep here t is equal to, see, ut minus 2. So here, now if you keep t is equal to 2, then if you keep t is equal to 2, then what will happen, u become u0, so u0 will be 1. So that what this does it mean, the signal value should not change, it should have the same value. So whenever we delay in time, so what we do, this is the representation of mathematical form, and this is the representation in graphical form. Whenever you delay in time, we move the signal towards right. Whenever we advance in time, suppose if we have to write this as t plus 2, then how we will do, what we will do, we will write it as like this. This is basically u t plus t. This is time advancement, because suppose if 0 was a reference, if you subtract, you have delayed it. If 0 was the reference, if you go behind the time, that means you have advanced with respect to the origin. Okay. The third is time scaling. What do you mean by time scaling? See, when we want to increase the speed, or we want to increase the speed or decrease the speed of time, then basically we use time scaling. How we do it? We multiply the time in argument by constant. So suppose for example, if you are having yt, here also it is written, if you have yt is equal to x, t is the basic signal. What you have done, you have multiply a constant a by in the time. So what will, if you multiply it by a positive number, it will scale up. If you multiply the number by a negative number, it will slow down. So how we will do it? See, earlier the signal, this was the basic xt signal. The signal was having value starting from t is equal to 0, it was going till t is equal to 2, and after t is equal to 2, it was having a 0 value. So now suppose if we want to, what we want to scale it, we want to speed up, what we will do, we will multiply by 2. So what you have done, so when you multiply by 2, what will happen, earlier this value which was going the value which was going from t is equal to 2, since now you have multiplied it by 2, means the time will reduce to half, because you have speed up, whatever signal whatever the speed of signal before multiplying 2 will be half of the current signal. So see here, earlier what was happening, suppose signal was getting 0 at what time, after t is equal to 2 seconds. Earlier what was happening in the basic signal, the signal was getting 0 at t is equal to 2 seconds. So now if we want to speed up, means speed up by what? Speed up by twice, So if we want to speed up the signal by twice, then what we will do, we will multiply by 2. So, see now earlier the signal which was getting 0 from t is equal to 2 has now become 0 after t is equal to 1. That means, earlier whatever was happening at t is equal to 2 second has now happened at t is equal to 1 second. So, this is basically we call as a speeding. Similarly, suppose if you want to write here as, suppose here if you want to slow down, here if you want to slow down, how we will do? See, this is the basically signal x t. If you want to slow down means what? Y t is equal to x t by 2. So, that means signal has to slow down, means earlier the thing, suppose signal was getting 0 at t is equal to 2 second. Now, since you have slowed the signal by half, that means it will take twice the time to reach this state. That means now the value will become 0 at what value? T is equal to 4 second. So, this is the representation of what? X t by 2. This is the representation of x t by 2. See what happened? The what duration has increased from, this is total t is equal to 4, this was total t is equal to 2. What has happened? The signal has taking more time to show it full behavior. So, that is called as slowing down. Okay. So, this was I have already discussed, this is basically slowing down of the signal. So, this was the duration of t is equal to 2. Since now we have multiply it by 2, it will get it as this. See, the signal expanded from 2 second to 4 second. Now, see, since now you have seen what is time scaling, what is time speeding up and what is time reversal. So, now suppose how we will do, take the example of different signals. Suppose this is one signal, this is one signal, this is the signal is made up of what? Suppose if I ask you to draw this signal, if I ask you to draw the signal, then you can what I have told you that you can draw the signal from using some basic elementary signal. What are the basic elementary signal? Unit step, unit ramp and impulse. If I ask you to make or you draw this signal, how can you draw? You can see the signal consists of unit ramp, some unit step, then again unit ramp. So, if we want to represent this signal in the form so we can easily represent this. How we can represent? So, first see what we are seeing. This is the signal x t. What we want to do? First step is we want to make time reversal. So, how we will make time reversal? What are the condition for time reversal? How you can identify time reversal? I have said just shift the image, just reverse the signal by 180 degree on the y axis. So, that here what will happen? See, this is the time reversal. Earlier the tip, the highest value was at t is equal to suppose 0.5. So, now it will come as earlier it was at minus 0.5, now it will come to plus 0.5. Again this tip was minus 1, again this minus 1 has come to 1. So, time reversal means just reversing the image on the y axis or make the axis as a mirror and just draw the mirror image. That is another way of drawing the reversal signal. Now, again what was the other thing? Now, this was the time reversal. Now, time reversal. Now, this is what? Time scaling. So, what I have told you, see earlier signal was expanding from what? Minus 1 to 1. What are the duration? This is 1, this is 1, 2. Now, we want to expand. So, what it will become? It will become 1 because it is scaling by 2. So, earlier duration was 2, now it will become 1. So, this is minus 0.5 to plus 0.5. This is time scaling. What is this? This is slow down. Slow down. See here in slow down. Earlier duration was 2, now we are slowing down by what? 2. That means duration size will be double. So, earlier it was 2, now it will become 4. now it will become 4. There won't be any change in the magnitude. See, till now whatever we have seen, whatever operations we have seen, in that the magnitude of signal has remained the same, magnitude has not changed. See, this was the highest value 1, here it was highest. So, magnitude is same, magnitude of signal has not changed. What has changed? It has changed its duration, it has speed up, it has reversed, but the magnitude of the signal has not changed a bit. Okay. So, now we will be seeing few operations by which we can also change the amplitude of the signal. Okay, before that we can see, suppose we have studied scaling and shifting. So, if we want to combine both operations together, then how we can do it? So, suppose this is basically a signal, that is xt, a rectangular signal which is starting from -2 is and is remaining till 4, and after 4 it is 0. And if you want to write x to t minus 2, that means what? See, there are two simultaneous operations happening in this signal. What? There is a delay and there is a delay and also there is speed up. There is a delay of 2 and also there is speed up of 2. So, how we do? See, basically there are two way of doing it. Either you can do shifting first, then scaling, or you can go by scaling first, then shifting. You can choose either of the method. In both the method you will get the same result, because any operation won't change. Whatever operation you do, see, that will the signal characteristics should not change. It should not change, only delay or this can happen. So, see how we can do it. See, so this is basically xt. If you write this signal modified form, it can write it as like this. What is this? We have to delay the signal by, so let us choose first method, that is delaying then scaling. So, see what you do, if you write x to t minus 2, first what we are doing? We are delaying by 2. What we are doing? We are delaying by 2. So, how we delay the signal? By 2, and also we are -2 means shift toward the right. So, this is the basically xt minus 2. What we have done? We have shifted this towards right by 2 seconds. This is a delayed signal. Now, this is done. Now, what we need to do? We need to scale up. So, how we scale up? What happens in scale up? In scale up or speed up, what happens? The duration becomes short, the time duration reduces. So, by what factor? By 2. So, earlier duration was from 0 to 6, means t was 6. If you delay it, if you speed up by 2, it will become 6 by 2, that is equal to 3. So, it has become 3. Okay. But suppose now this is the method where delaying then shifting, delaying then scaling. Now, suppose you want to, what you want to do? You want to scale first then delay. So, what we will do? See here, x to t minus 1. So, first see what you will have to do? First you scale or you speed up. So, you will take 2t, how will we draw 2t? So, 2t will reduce it. So, it will become -2 to -1 and it will become 4 to 2. So, this is x to t. Now, what is left? This is means speed up has been done. Now, what we are required to do? We are required to delay by 2. See, since now you have already scaled it by 2, then now you cannot make it delay by 2. You will have to delay it by 1 second, because you have scaled the time already. So, when you have scaled the time first, then you have to, the delay time will also get reduced, because you have speed up first. So, what will happen? Earlier which were delaying by 2 in delaying first and scaling method, here will only delay by 1. So, what will happen? Delay it by 1, it will become, it will shift toward right, it will become 0 and here it will become 3. So, again you see both the output are same, both the output are same. Either you delay first or scale first or delay, in both the cases output will remain same. See, this is another example. this is another example here, this is the basic signal xt. Now suppose if I want you to tell me the type of this signal, then how can say, see this signal is symmetric about origin. So this is the example of what? This is the example of what? Hot signal. Also if I want to ask what is the duration of the signal or what is the type of signal, it is energy signal, power signal, or neither energy nor power signal. So what can you say? See, since this signal is having a finite duration, this signal is having finite duration, so this comes under category of energy signal. Any signal which is having a finite duration or finite amplitude, it will come in the category of energy signal. So this is example of an odd and energy signal. Now see, so this was basically xt. Now we are required to find x to t minus 1. So first let us delay it by 1. So how we delay? Delaying means shifting towards the right. So we have shifted towards right. See, this is delaying. So this is basically delay by 1 second. This is delaying by 1 second. Again, now what? Now after being delayed, what we are required to do? We are required to scale it by 2. So scale it by 2 means reduce the time duration. So earlier it was -1, it was 3. So here it will become, see you can, it is very small, here you can see it is -1 by 2, here it is 3 by 2. So what we have done? We have squeezed the time because we have scaled up. Okay. Similarly, another also we can equate. See here, scaling first. Here you have scaled it first. Now if you delay, what you will have to do? Since you have scaled it first, so now the delaying will become what? Earlier it was delaying by 1, so now it will delay by 1 by 2. So scale, then shift towards right by 1 by 2. So you can see both the result are same. Okay, this is another operation is amplitude scaling. Suppose this is a unit step signal which is having magnitude 5. Now if you want to scale the magnitude, now if this is basically 5 ut, or basically this is ut. Ut means what? Having magnitude 1. Now if you want this signal should have 5. So what we will do? We will multiply 5. So we will write it as 5 ut. So this is ut, magnitude is having 1. This is ut, and this is 5 ut. Okay, this is basically called as amplitude scaling. These are the example of amplitude scaling. See, this was the value. What we have done here? We have this was a basic signal xt. We have multiplied 1 by 2, means it will be shrink by 1 by 2. Earlier the peak was 2. Now the peak will become 1. Here again see, it was having 2 xt was this. Now if you want to make minus 2 xt, what you will have to do? Minus multiplication of -1. So this will reverse the signal. So whenever now reversing is what? Earlier where we are getting positive peak, negative peak, there will get positive peak, and earlier we were getting negative peak, there will get positive peak. This is basically amplitude scaling. Okay. Now addition of signal, basically these are, see now when you add two signals, suppose how we add two signals, suppose this is ut and here we have 5 ut. So if you add this signal, what we will get? We will get 6 ut. What is the method to find it? Add both the signal, get the value for all the instant of time, and then add. See, this is the example of addition. See, there is basically ut, and at x here we have minus ut minus 2. So how will add? For adding, what do you do? You have to move from one side to other and add their instant value. You have to add the instant value. See here, at this instant value is 1, value is 0. This instant value is 1, value is 0. Here value is 1, value is -1. So add all the instantaneous value and you will get the final value. Similarly with the example, similarly the case, the multiplication, multiply all the instantaneous value. Okay, you have to add, this is the instantaneous value, get the instantaneous value of both the signal and multiply, then you will get the final result. Again, suppose now if you want to, the basic question comes is, suppose if someone asks you to draw a signal like this, which is having a slope of 4, which is having a slope of 4, this is 12. So, if someone asks you write this signal in a mathematical form, how we can write? See, basically there is one unit step signal, suppose this time is 2. So, the earlier what we will do, first we will write a ut signal, okay. So, okay, leave it. Now, we will in the next lecture we will see that how we can represent, suppose we are given some signal, and we need to represent this mathematical form, represent the signal in mathematical form, then how we can do. So, we can easily say that they basically this signal is consist of a unit step, a ramp, again a unit step. So, in the next lecture we will see how you can represent a mathematical form of signal into, or a signal in graphical form into mathematical form, or if a signal is given in mathematical form, how you can write the signal in a equational form or in mathematical form. So, in the next lecture we will see this. Okay, thank you.